Okay, dear students, how are you all? So today I just have brought one final exam for you. It's an applied mathematics 1B final exam. Now I'm going to show you how you can solve some all questions available in this final exam. So I would like to recommend you to subscribe this channel because the channel is containing a lot of tutorials for different applied mathematics courses. Now, when I directly go to this final exam, look, as you see, the final exam is given 3 hours to be done, and there are 7 multiple choices, 8 fill in the blank space questions, and 4 workout questions. So I'm now going to show you how you can solve all these questions. So let's directly go to see how the final exam looks like. So as can be shown, 7 different kinds of multiple questions are available here, and there are also 8 different kinds of in the blank questions again, and 4 different workout parts are also available, as you see. So I'm going to do all this for you because I strongly believe that this will help you in order to be fruitful in your study or in your course. So here I directly go to the first question. So it says find the angle between the vectors u10 minus 1 and v110. As you studied, students, the angle between two vectors can be obtained by using this formula, which is cos inverse of the dot product of the two vectors divided by the product of the two norms. So here, as can be shown, the vectors must be non-zero in order to have a meaningful output here. So we need to first find the dot product of the two, and next we need to determine the norm of these two vectors. Okay, so the dot product of the two can be obtained in this manner, as you studied. 1 times 1 makes 1, you see, and 0 times 1 makes 0, and negative 1 times 0 makes 0, so the sum comes 1. So as you see, the dot product is now determined, the numerator is now known, so we need to determine the denominators. So the norm of u has to be calculated, and it is calculated as the square root of the sum of the square of the components, as you see. Here 1 squared, 0 squared, and minus 1 squared must be considered. So this makes radical 2. Similarly, the norm of v must be calculated, and the norm of v is calculated by the square root of the sum of the squares of the components, which actually is 1 squared plus 1 squared plus 0 squared, which actually is again radical 2. Now, dear students, u dot v is already obtained, their norms are already obtained, so next task is a matter of substituting. So look, cos inverse of u dot v is already 1, and the norms are radical 2 and radical 2 again. So this makes 1 over radical 2 times radical 2 is 2. So cos inverse of 1 over 2 can come. And you need to think of an angle, a special angle, whose cosine makes 1 over 2. And as you know that it is 60 degree, and the equivalent radian for 60 degrees pi over 3. So the answer for this is going to be B. As it is stated here, it is B. So the first is now solved, and going to the second one, you are asked to find the limit of this function or expression. So how are you going to find this? So simple. What you need to do is you must have a certain simplification thing here, and that is, look here, the minus sign is used, so you need to multiply by the plus of this expression for here, as you see. Doing this never changes the given expression, because we are multiplying the numerator and the denominator by the same expression as can be shown. But in doing this, we can change the non, you see, evaluated expression, the non to be evaluated expression to, you see, some expression that can easily be evaluated by its limit. So this is going to be like this now. Look, you can consider this as A, and you can consider this one as B. A minus B is appearing here. So this is A plus B. So A minus B times A plus B is going to be A squared minus B squared. So when you remove this radical expression, you do have x squared plus 1 plus x as it is. This is your x squared, right? And minus, look, x times x makes x squared. The one you said b squared comes. Then here you are having 1 as a denominator, so 1 times this is the expression itself, as can be shown. Now from this, you see, you can now simplify x squared by x squared, and then 1 plus x comes, and the square root of x squared plus 1 plus x follows. Now look here, student, that the numerator is having degree 1, so here also we are having degree 1, even though degree 2 looks, the degree of the denominator is not like that because it's under radical. So we need to multiply both the numerator and the denominator by 1 over x to put the expression in such a way that it can easily be analyzed. So as you are multiplying both by 1 over x, look, 1 over x times 1 makes 1 over x, and this is plus 1 because x times 1 over x makes 1. So look, 1 over x, as you are multiplying to this, it can be, you see, inserted inside this radical expression by taking 1 over x squared, right? 1 over x squared, 1 over x squared, 1 over x squared. So as you are multiplying x squared by 1 over x squared, it will be 1. And here you do have 1 over x squared plus 1 over x can come. And here x times 1 over x is 1. So as you see, the expression looks like this. So further simplification of this makes like this, as you see, 1 plus 1 over x. Now here 1 can come plus 1 over x squared. This is 1 over x, and this is 1. So as x goes to infinity, this is approaching to 0, and this is again getting closer to 0 at a faster rate because it's 1 over x squared. This is 0 again, and this is 1. So 1 over, you see, this makes 2 because 0, 0, 0 plus 0 is 0, 0 and 1 makes 1, radical 1 is 1, 1 plus 1 makes 2, so 1 over 2 can come, which actually is 0.5, right? So the numerator makes 1, the denominator makes 2, so 1 over 2 is 0.5. So this is available here in C, so you can make your choice to be C. Now proceeding to the next one, question number 3 says, which one of the following is true about this function f? And it's talking about critical number, as you see. And how do you define a critical number, students? A critical number is a number in the domain of the function where the derivative of the function at that particular critical number is either 0 or doesn't exist. And what you need to know in another point is, you see, critical number, as the name implies to you, is a critical one. Because if your function is having local extreme values, the critical number is a place where you can detect these local extreme values, either local max or local mean. But it doesn't mean that at every critical number we do have always these local extreme values, okay? Having this into account, when you come to the solution of this one, this is a definition I told you earlier. So a critical number is a number in the domain of the function where either the derivative is 0 or the derivative doesn't exist. So if a function has a relative extreme value, it occurs at the critical number, look. But it doesn't mean that always at the critical number there always exist what? Extreme values. As you see, having a critical number doesn't give a guarantee for existence of extreme value at the critical number. So if you see B says if C is a critical number of f, then f of C is a local extreme value. No. There are cases where you don't have this kind of condition. For example, take f of x equals x cubed. The critical value here is 0 because the derivative of f with respect to x is 3x squared, and 3x squared is 0 at 0. So even though 0 is a critical one, we don't have relative extreme value at 0. Right? So the answer for this is going to be B, because B is false. But if you see the others, you see the first one, the definition basically, and when you come to the third one, look, the third one is again the reason why we are talking about the critical number. If f has local extreme value, it occurs at the critical number. It is true. It occurs at a place where either the derivative is different from 0, or I mean the derivative is 0 or the derivative doesn't exist. So the answer for this is going to be B. So as you see, it is B. And proceeding to the next one, we have question number 4, and you have been told that a certain function is given, and the integral from 0 to 10 of that is 17, and the integral from 0 to 8 of that function is 12. So the question is to find the integral from a to 10 of this function, assuming that the function is integrable or continuous within the interval 0 to 10. So as you know, if the function is continuous on the interval 0 to 10, then the integral from 0 to 8 of the function plus the integral from 8 to 10 of the function must be the same as the integral from 0 to 10 of the function. This is one property of the integration. As long as the intervals are not overlapping, we can have this kind of condition. Now, from this, you are asked to determine this value. You see the integral from 8 to 10 of f of x dx. So in order to know what this is, you need to shift this expression to the right. And this turns to be like this. You see, 0 to 10 f of x dx minus 0 to 8 f of x dx. So from this, the value of this is already determined. It has been said that this is 17. Look, here it is. Directly we put 17 here, and this value is also determined, and it is 12. So we are having now 17 minus 12 as the value for this one. So clearly this is going to be number 5. So the answer for this is going to be C. I hope you have understood how we can find solution of these 4 questions, right?